Welcome back to day 7 of our final exam review unit. For today, we are going to be reviewing solving quadratics. So our goal for today, given a quadratic equation, you will be able to factor and solve. All right, so let's go ahead and take a look. Our first goal for today is going to be to factor, and then we'll take a look at solving. So if we remember, there's 3 different ways that we can factor our quadratic equations. All right, factoring is when we're going to take an expression and we're going to break it up into smaller units that can ultimately be multiplied back together to get back to the original number. So we want to take the expression, we want to break it down into its smaller parts. So our first way of factoring is what we call greatest common factor factoring, GCF factoring. So what we're going to do is we're going to look at the terms in our expression and we want to think, well, is there a number or a letter that goes into both of these? Well, 24 and 6, well, 6 divides into both of those. And I look carefully, they both have an x. So that means our GCF is 6x. Okay, so to factor using GCF, what we're going to do is we're going to take that 6x and we're going to put it on the outside of a set of parentheses. Now what we're going to do is we're going to distribute out that 6x. So we're going to divide by 6x since we're putting it on the outside. Now 24x squared divided by 6x is 4x. Then the minus stays the same, and 6x divided by 6x is simply 1. All right, and we factored. We've broken it down into its simpler parts. All right, let's take a look at the second one. So if I look carefully, d squared minus 2d. Well, there's no number that goes into both of those except for 1. But if I look carefully, they both have a d. So my GCF here is just d. So I'm going to divide a d out of the original expression, which is I'm going to give us d minus 2. And we've got it. All right, our second way to factor is called difference of perfect squares factoring, DOPS. Now, difference, that means it has to have subtraction. All right, and perfect squares means, well, everything has to be a perfect square. So let's review our perfect squares. All right, so our perfect squares. Well, first we have our variables. Any variable to an even power is a perfect square. So x squared, y to the 4th. We could have m to the 6th. We could have z to the 8th. So as long as that power is even, it's a perfect square. Now our number perfect squares, all right, for instance, would be 2 squared would be 4, 3 squared would be 9, 16, 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. All right, so on and so forth. All right, so let's go ahead and take a look here. So if I look carefully, are both of these perfect squares? Yes, they are, and there's subtraction, which means I can use the DOPS method. So to do that, we're going to set up 2 sets of parentheses. The first thing we're going to do is take the square root of the first term. So the square root of m squared is m times m. Now, we want to have a minus, so we need to think, well, we need a positive and a negative to multiply to a negative, so we get 1 plus and 1 minus. And then we're going to take the square root of 64, which is 8. So 8's going to go second. And you've just done it. You factored using the DOPS method. All right, let's try it one more time over here. So if I take a look, 9's a perfect square, y squared's a perfect square, 36 is a perfect square, and it's minus. So we can set up our 2 sets of parentheses. One's going to get a plus, one's going to get a minus. We take the square root of y squared, and we get 3y and 3y. We take the square root of 36, which is 6 times 6. And you just factored using DOPS. All right, now let's take a look at factoring using trinomial factoring. And now trinomial factoring only works when you have 3 terms. Now everybody, there is a goof on your worksheet. This middle term here is supposed to be a 10 on your worksheet. It does say 11, so go ahead and fix that first. It should be a 10. Okay, so to factor using trinomial factoring, we want to take this, we want to break it down into smaller parts. So we're going to set up 2 sets of parentheses. Now the first thing we're going to do is we're going to look at this first term, and you need to think what times what will give you y squared. Well, that's y and y. Now to find out what's going to go after those y's, we need to think very carefully. We need to find two numbers that multiply to the last number and add to the middle number. So let's think, can you think of two numbers that multiply to negative 24 and add to positive 10? Well, if they multiply to a negative, that means it has to be a negative and a positive. And if they're adding to a positive, that means the bigger number is going to be positive. So let's think. I could do 6 times negative 4, but that does not add to positive 10. I could do 8 times negative 3, but that does not add to 10. We could do 12 times negative 2. Does that add to 10? Yes, it does. So we're going to go ahead. It's going to be plus 12 and minus 2. And we have our final answer. All right, let's try one more. So x squared minus x minus 20. So it's a trinomial. There's 3 terms. So I want to break it down into 2 parentheses. X squared is my first term, so I'm going to put an x and an x. Now we have to think of 2 numbers that multiply to 20, negative 20, and add to negative x. So if they multiply to a negative, it has to have a positive and a negative. And if it adds to a negative, the bigger number is negative. So if I think carefully, that's going to be negative 5 and positive 4. And we've done it. Okay, now we also have one more. It's not a new way of factoring, but it's a different directive. If you hear the word factor completely means you're going to factor twice. Now when you factor twice, the first way you're always going to factor is GCF. After GCF, then you're going to use the dots, or you're going to use the trinomial. So let's go ahead and take a look at our first example. Factor completely. So first we have to use GCF. So what do these have in common? They have a 3 in common. So I'm going to factor it out. Now we want to look inside of the parentheses. We want to factor this again. There's only 2 terms. They're both perfect squares, so I'm going to use the dots. So the 3 stays on the outside, 2 sets of parentheses. One gets a plus, one gets a minus. We take the square root of x squared. We take the square root of 4. And now we've got it. All right, go ahead, try the next one on your own. All right, let's go ahead. Were you able to find 2 parentheses x minus 3 parentheses x plus 2? And we've got it. All right, so that's our mini review on factoring. So next, we have to review how to solve a quadratic. So solving quadratics, solve for the following values of x. Find the solutions, roots, zeros. So these are just your different names for the answers. Now, when we solve quadratics, the first thing you want to do is set your equation equal to 0. So for instance, ax squared plus bx plus c, you want to make sure that it's equal to 0. Then you're going to factor, so we're going to get our parentheses. Then we're going to t-table and set each factor equal to 0. And then at the end, you're going to solve for your values of x. All right, so your zeros, your solutions, your roots, those are the answers you get at the very end. Remember, if x is squared, that means you're going to have 2 solutions. All right, so let's go ahead, let's practice this. So our first example, solve each equation. Remember, you always want to try GCF first. Then you're going to try the dots method. And if that doesn't work, then you're going to try the trinomial method. So let's take a look here. So number 1, the first thing we have to do is set it equal to 0. So I'm going to subtract the 20 to the other side. Now we want to write this in standard notation. So the x squared goes first, the x goes second, and then our constant. Now if I look carefully here, there's 3 terms. There's no GCF, so I'm going to use trinomial factoring. I need to find 2 numbers that multiply to negative 20 and add to -1, and we did this on the front of the worksheet, and that's going to be x minus 5 and x plus 4. So now that we factored, we're going to tee it up. We set each factor equal to 0, and then we solve. So we're going to add 5 to both sides, and we get x equals 5. And then over here, we subtract 4, so we end up with x equals -4. And I know a lot of you know the shortcut that if it's a -5 in the parentheses, you end up with a +5. If it's a +4, you end up with a -4. All right, let's take a look at the second example. So the first thing we have to do is set it equal to 0. So I'm going to subtract the 2d. Those cancel, so we're going to get d squared minus 2d equals 0. Now we need to figure out how are we going to factor this. Well, the first method we always try is GCF. If I look carefully, they both have a d. So I'm going to put the d on the outside, and then we get d minus 2 for the inside. We can tee it up, so we get d equals 0. D minus 2 equals 0. I don't have to do anything to solve here. There's my answer, and over here we add 2, and we get d equals +2. All right. Let's go ahead then, and number 3, the first thing we have to do, well, we have to set it equal to 0 and get rid of those parentheses. So we're going to go ahead and distribute. Y squared minus 3y equals 4. Now we have to set it equal to 0, so I'm going to subtract the 4 over. So y squared minus 3y minus 4 equals 0. Now we're going to use trinomial factoring because there's 3 terms. So y, now we need to think of 2 numbers that multiply to -4 and add to -3. So that's going to be -4 and +1. Now we can tee it up. Y minus 4 equals 0. Y plus 1 equals 0. We add 4, so y equals 4. Over here, we're going to subtract 1, so y equals -1. All right, example number 4. The first thing we have to do, set it equal to 0. So we're going to subtract 3x. Now, when we rewrite this, we have to write it in standard notation. So x squared. Then you put the x minus 3x. Then comes the constant. Okay, so once again, there's 3 terms. We're going to use trinomial factoring. So x squared, so it's x and x. We need to find 2 numbers that multiply to -28 and add to -3. All right, did you get it? All right, so that's going to be -7 and +4. So now we can tee it up. X minus 7 equals 0. X plus 4 equals 0. So we end up with x equals +7. X equals -4. All right, next up. Number 5. The first thing we have to do is set it equal to 0. Now we always want our w squared to be positive. So we're going to keep that where it is. And we're going to bring over the 8w and the 15. So minus 8w plus 15, those cancel. We get w squared minus 8w plus 15 equals 0. So now we're going to factor it up using trinomial because there's 3 terms and there's nothing in common. So w squared, we're going to put w and w. Now we need to think of 2 numbers that multiply to +15, add to -18. Now if they multiply to a positive, that means it has to be positive or negative. Since they add to a negative, that means we're going to have a minus and a minus. Now let's think of those 2 numbers that multiply to 15, add to -8. So it's going to be 5 and 3. So now we're going to tee it up. Set both parts equal to 0. All right, and then we get w equals +5 and w equals +3. All right, last question for today. Let's take a look here. Remember, if x is squared, that means there's going to be 2 solutions. Step number 1, set it equal to 0. So I'm going to bring the 81 to the other side. Now we're going to factor it up. So x minus 9, x plus 9 equals 0. We use dots. So we end up with x equals 9 and x equals -9. All right, our goal for today was to factor and solve.